Hello everyone and welcome to this latest video discussion of part of the RICS Tech Partner Programme. My name is Andrew Knight and I've been with RICS for nearly 13 years now. I currently work in our thought leadership and analytics part of the organisation, and my role is to look at the impact of data and technology right across the built and natural environment. And with over 110,000 members worldwide, working right across that full land and property life cycle, from land through planning and development, construction, valuation, finance, brokerage, building operations, building surveying. It's obviously a very, very rich canvas upon which data and technology in all its forms is having a really profound effect. And indeed, our members also work across all the major asset types, whether that's land itself, residential, commercial in all its forms, alternative assets and infrastructure. So once again, a very broad spectrum across which our members are working with different asset types. And today I'm really glad to have Mike join us from BiocareUV. So welcome to the chat, Mike.
Thank you, Andrew. Nice to be here.
Great. Well, before we get into the kind of the science bit, as they say, it'd be great just to have a little bit of your backstory, actually.
Sure, and just to reassure you and the other listeners, there won't be much science because I'm not a scientist, so we won't get into too much detail. Although I have become latterly a bit of a scientist. So really, I'm ex-defence. I'm a Royal Air Force officer for 23 years. I was an aviator for the whole of that time. Got my own squadron, and towards the back end of my career, got into drones. And left and got into aerospace and realized actually on leaving, on transitioning, I did an MBA and it sort of opened my eyes a little bit more to what business was. It wasn't just a natural progression of your career, it could actually be more interesting. So I was in aerospace and defense for about 8 of those 14 years since leaving the Air Force. The last 6 I've been starting my own companies.
Thanks, Mike. Well, we joked about not being too scientific, but my first question kind of delves into the science to some extent, because obviously post the pandemic, there's obviously a lot of focus now on pathogens and superbugs and various other kind of threats to our health, both in terms of in buildings and hospitals and all those kind of things. And obviously with what you're doing now, around far UVC, I think, our viewers will probably want a bit of an explanation on what exactly is far UVC.
So that would be a good question, and pretty much the same question I asked when I first came across it, which is a few years ago now. So we came across it because of the Ebola crisis in Africa, and obviously that was affecting aerospace and the ability to move people in and out of that continent. And when I went and had a look at what technologies were available to perhaps help with that, particularly on board aircraft, this was one that I came across that showed a lot of promise. So and then since then I've been reading, and I've worked with virologists and bacteriologists, and I've become a pseudo-scientist. I wouldn't pretend to be in their league, but at least I understand it now. And what is it? So very simply, the way to look upon this is there's the electromagnetic spectrum. We all know what X-rays are, and ultraviolet and infrared. And with sunlight, you get all forms of ultraviolet. You get the whole spectrum. UVA, UVB, and UVC. And UVA and UVB we get in daylight, and they are the kind of things that will give us sunburn. UVC doesn't get through the outer atmosphere, so pathogens have never really been exposed to it on the surface of the Earth, so they have no resistance. And all it is a very small subset of the UVC waveband. We call it far UVC, and it's basically between about 200 and 235 nanometers, with a peak. And the important bit is there's a peak at 222 nanometers where you get this really happy coincidence. You get very high germicidal effect, and you get, and I'll use the word carefully, but it is correct. It is safe for humans to be around. Any other wavelength, particularly up at around 254 nanometers, which is the standard germicidal wavelengths, they are not safe for people except in very, very small doses. Far UVC is the kind of thing that finally, now that we've got modern technology to filter UVC, it's the kind of thing we can have around people and therefore install in buildings and give us a degree of pathogen protection.
So as you say, sorry, carry on, Mike.
Yeah, and I was going to say that there is a subtle difference in how it kills as well. So UVC does interfere with the DNA of a pathogen, and it stops pathogens replicating, breeding, if you want to use that word, but replicating is the word the scientists use. And so it tends to take slightly longer to kill. With far UV, the photons come out with a particular energy level that means that when they hit the skin, the former of a pathogen, they break it open, and it's pretty much an instantaneous kill. So 3 great coincidences: it's germicidal, it's quick, and it's safe. they all happen at or around far UVC wavelengths.
And I guess that, in a small way, in the same way that you've been introduced to this kind of science, given what you're now doing, and obviously, I'd not heard of things like HEPA filters until COVID. How does it compare to the alternatives? Because obviously there's a lot of focus now with, modern buildings, in terms of looking at how the HVAC is working in terms of filtering fresh air, and say things like HEPA filters. What's the performance of far UVC compared to those kind of technologies?
Okay, so to be fair to some of those technologies, their performance, it can be good, but it's more the instantaneous effect that we're really interested in. So if I talk about how we or how we came to far UVC from a short list of what could we do to improve aircraft, bearing in mind that my aerospace companies, we effectively upgraded very, very rich people's private jets. It was a pimp my ride for private jets. That was the business. And we were getting aircraft coming to us during the COVID period, which had been ionized, or they'd had sprays put around them, and some very important things were happening. The rubbers were degrading. Some of the anti-inflammatory stuff that was anti-flammable material that was embedded in some of the materials inside the aircraft was leaching to the surface, therefore making the aircraft non-airworthy. And there was just general degradation. So far UV didn't provide any of those issues for aviation. So we thought, well, we'll give it a go. The more we got into it, the more we realized that actually it's got a number of advantages. If I take HEPA filters, I'm ex-Air Force, so I understand this at some level. Nuclear, biological, chemical type warfare, you don't want this stuff to come into the cockpit. So we've always had HEPA filters in military cockpits. But the testing that's been done has been done at a pretty severe level, as you can imagine. And then Boeing and Airbus have replicated that testing for their HEPA filters on civil jets. And they will work really well down to about 300 nanometers. Below that, pathogens, if they're very small, and to give an example, COVID's 30 nanometers, a tenth of that size, it's going to go through a HEPA filter, particularly at high flow rates, very much like it's fresh air. And so HEPA filters will pick up the larger molecules which may have pathogens attached to them. They won't pick out the individual pathogens. And ultimately, of course, those larger molecules then break down and come back into the cabin. So there are advantages and disadvantages to lots of these systems. But what you get with far UV that you don't get with the others, including upper air UVC, which is just pointed away because it's dangerous wavelengths, or with air conditioning, which tends to recycle upper air, but not the bottom 2/3, which is what we're breathing, is when a UV light comes on, everything below it is immediately getting hit by far UVC wavelengths, as long as it's within line of sight, and you're killing pathogens. And you can do that 24/7. And so it's reducing your cleaning workload, it's sanitizing the air, and sort of the net advantage is quite significant. There are, with every cleaning and sanitization method, secondaries. So most of them will react with things in the air and create other issues. But far UVC, properly filtered, properly managed, with ventilated air, even SAGE have said it's the up and coming solution for safe breathing.
And you intimated earlier about the fact that because of the particular kind of part of the bandwidth it's emitting, that it is safe. But can you perhaps explain a bit more? Because obviously, understand UVC has been used within AC units, but obviously currently kind of UVC in its broader sense is not really allowed around human beings. So how have we managed to get to a point where we have a kind of a safe thing to deploy?
Yeah, I mean, it's a good question. For those who think that UVC is new, it's actually been around since about the 1880s. And it was held in high regard for decades. And around 1924, 1920s anyway, there was trials in Boston and in London where they had a look at tuberculosis rates amongst children in schools. And retrospectively, they've gone back and had a look at that data and gone, no, actually, it did have a great effect. But at the time, those children were going back and living in slums and coming back to school with a tuberculosis. So the results were skewed. And then ultimately, what you get is the rise of antibiotics and the ease with which antibiotics can suppress superbugs. And so they have sort of got into vogue, and UVC has taken a bit of a back seat. It's still used in some sanitization, for example, in clean rooms in hospitals. and in cleaning water, but it's never really been in vogue because of the rise of antibiotics. But latterly, we've had the COVID pandemic, which has obviously raised all of our awareness of this issue. But also, there's a rise of superbugs which have become antibiotic resistant, and those two things together have sort of given it a second lease of life. So everybody's gone back and had a look at, well, is it safe? And there are literally hundreds now of reports on skin safety and on eye safety that you can refer to, which shows that far UVC, properly filtered and properly applied, is perfectly safe. It won't go through your outer layer of skin. The dead layer is effectively what stops it, and it doesn't penetrate much beyond the outer tear duct layer of the eye. So in America, for example, what's happened is they've done a lot more testing, and they've come to a conclusion that the limits can be raised for far UVC, and that's what they've done. They've raised the limit roughly 20-fold for skin and 8-fold for eyes, so net 8-fold for human occupation, and that's kind of the start of it, really. And the rest of the industry is highly regulated. For those of us who want to work within regulations and not cut corners, it's perfectly safe to apply in a workspace.
And I suppose, I mean, that's the logical next question from my perspective, is what the regulatory environment looks like, because clearly, as you've said yourself, there are issues around filtration, obviously the way it's deployed. So what's the regulatory the regulatory environment look like to make sure this can now be taken to market in a way that's safe and people can then trust the way it's being deployed?
So it's well, it's quite a uniform regulatory market, fortunately, and it's only just starting to break up, but in our favour. So ultimately, most of the world's regulations, I think almost exclusively the world's regulations regarding UVC exposure, come from the US or stem from the US. And there are these two bodies there. There's the ACGIH, which is the American Conference of Governmental Industrial Hygienists, rolls off the tongue. And then there's ICNIRP, which is the International Conference of Non-Ionizing Radiation Protection, ICNIRP, I think that's correct. And between them, they come up with regulations which pretty much exclusively across the board said that for any UVC exposure, the maximum you can do in an 8-hour working day by way of dose, so that's millijoules over time, is 30 millijoules total UVC exposure. And inside that, the lower down the scale you get, so the closer you get to far UVC, the greater percentage of that 30 millijoules you can have inside your block. So if you're only putting out 222 nanometers, then you can have up to 23 millijoules in that one wavelength. So it's in your interest to filter to that and there or thereabouts, and then you'll get around 30 millijoules, but no more than 23 inside 222. And that regulation has gone promulgated all around the world. In Europe, we have this regulation, EU regulation 2006-25, which is that. It's 23 millijoules stroke 30 millijoules total. And it still works, and you can still kill pathogens perfectly well. It's relatively easy to kill what we call non-enveloped viruses. So that's a coronavirus. In air, that only requires between 1.61 and 2 millijoules. So inside a working day, inside a block of air that you're breathing, you would kill at maximum exposure every bit of coronavirus in there 12 times over inside a working day, which is pretty effective. But in the US, they've now changed. So ACGIH and ICNIRP in the US approved a change in their regulations in January, what are we into now, 21, I think, possibly 22. And as I say, they went up to 479 millijoules for skin and 161 for eyes. It's roughly those sort of numbers, which of course opens up the market there. And we're already seeing that, and we're seeing some pretty large institutions now mandating far UVC when they either build a new building or they upgrade legacy estate. So I suspect that over time that proliferation will happen around the world. European Union with 28 nations is going to be a bit slower, but here in the UK, now that we've left, we could adopt it relatively quickly. But of course, we've got to go through that whole process of getting it adopted. But it's definitely coming.
Well, having covered the science and the kind of regulatory and that kind of background, what was the origin story of BiocareUV itself? I mean, you explained obviously your aerospace background, but what made you sort of take the jump and think, well, let's put this together and commercialize it?
Yeah, so for us, it was just it was a bit of a cottage industry, a level of interest during Ebola. You know, let's go and read a little bit about this, and we talked to a few far UVC providers to see what it was all about, and then I just had put it on the back burner in the back of my head, and then coronavirus came along, and like many facilities managers, I imagine we all went tumbleweed in aerospace. It was dreadful. There was nothing flying. If you were in aerospace, in terms of maintenance and upgrades, the market died overnight. And we had these electrical engineers who were very clever chaps. We had an approach to quality, which is absolute, because that's what aerospace requires. And we had a broad awareness of far UVC. So I was the strategy director, and I said, let's diversify. We've got nothing else to do. It was pointless waiting for aircraft to come in for years. So yeah, we can put people on furlough, or we can keep some of them in work and use their skill sets and have a go at something else. And that's what we did. And we were very lucky. We went out and applied for grants through Innovate UK, which is an organisation I can't talk highly enough of. And from those grants, we made some prototype products and played with the science a little bit and created some relationships with universities. And then we were able to make some products that were, I would say, pre-production prototype level, but extremely high quality. So we took those, we made some early revenues, we won some more grants, and then we stood the company up on its own. So BioCare, the company is now fully independent of the aerospace arm in its entirety. We've got our own engineers. And then we went out and got investment. We were very fortunate to get one of the Camprad family on board, who own IKEA. So he's a great sponsor and an angel to have on board, and very interested in what we're doing. What we're doing right now, I'd say, is still primarily R&D. So we're still trying to make new products. We're doing some very interesting things with the wavelength, which I won't talk about here. It's under NDA, but things which really are market leading. We're involved in trying to drive the products towards LED, but that's years away. It's extremely hard to create LEDs with the power that this requires, because it's not about light, it's about sanitization. You've got to kill. But we've got 4 products, and we've independently tested literally till the cows come home. I mean, all the products are UKC ACE, but independently tested, even though we can self-certify because we come from aerospace roots. And we have more certificates than I can shake a stick at for photobiological safety and efficacy and all of the sciencey type things that I never even knew existed until 3 years ago.
So I mean, how would you sort of describe the kind of the technology of delivering it? Because obviously there's the science, and then there's actually making something that's viable from a technological and commercial perspective. Where are we on that kind of journey, that journey towards a mature technology that's going to be relatively simple to deploy?
Yeah, so I would say, so bear in mind that why has far UV not been around before, sort of around 2005, other than in academia? Quite simply, it was very difficult to build this. So there are elements to it. It's the mix of the gases, it's the pressure that you put them under, it's the way that you excite them. That's why these lamps are called eczema. You excite them with electricity, and putting all that together in a coherent product was extremely expensive and frankly very, very difficult, and it was unstable. So so what we get now is, first of all, the US has recognized that there is potential, so they've changed their regulations. That then creates a market, and that then creates a little bit of momentum, so that's great. I would say that here in the UK, and as far as I'm aware, we are still the only European manufacturer of far UVC end-to-end. So we do everything from that mixing and pressurizing and building electrical boards inside a glass quartz container, all the way up to the other end of it, which is telling somebody how to install it. So that's the software and understanding the safety side of it and doing all that analysis, and everything else in between, including building the products. A lot of companies, they will take a Japanese emitter and stick it in a box and relabel it. So that's what I mean by end to end.
Yes, no, I
We
understand.
don't particularly like doing the installation. We look for partners, you know, electrical partners, people who understand lighting systems. We look for them to do installation and maintenance, because it's just not what we do. But the maturity, it's there now, and you know, we've got launch customers. We're perhaps going to talk about them in a moment. I would say that, you know, what stops us getting to market in a major way tomorrow, and the answer is trust. So if you imagine driverless trains, I remember driverless trains coming out on Top of the Pops. I'm showing, not Top of the Pops, sorry, Tomorrow's World. I'm showing my age here now, back in about 1974, and saying that this is definitely coming, and it wasn't until what, 1995 that they appeared at Stansted. because they had to go out and regulate it. And then 1995 driverless trains, and it's what 2015 before Tesla would have a go at producing a car, and even then it's struggling. So public trust is a big issue, and it's got two sides. Are they safe? And it's the same as telling somebody who's never seen an X-ray before, go and stand in an X-ray. People get a little bit averse to it until they understand that it's very regulated and very safe. And then there's efficacy. If you can't see what it's doing, how do you know what it's doing? And why would you spend your money on that? And that's where the software comes in, because we want that. We want everything to be independently tested, and then we want the maths to be really robust. And then we want our customers, therefore, to be able to see that correlation, and then potentially also, and we'll talk about this, through the software to see what it's doing in real time. I use the word see carefully. Yeah. So that's the eczema lamps. LEDs, talking to the industry and to academia that we're helping, we're still at least 8 to 15 years away from an LED with anything like the power required. So where we are now is overcome the trust issues and then get the cost down. We don't want to get the cost down by, with the greatest respect to our Chinese colleagues, going to China. We're a British company. We're very proud of what we do here in Britain. And we try and maintain a British supply chain and very high quality. But obviously, we need volume, therefore, to get the cost down to a Chinese level. But we are getting there.
Well, you've covered some of the pitfalls there, and I guess it's not unusual for any kind of step change in a way of addressing a certain problem for there to be these barriers of inertia and concern about a new and perhaps a perceived new technology when ironically it has been around a long time. In terms of the customers you are working with, who are the kind of customers and what's driven them to overcome those kind of perceived or real barriers in their minds?
So I've a list a few of the customers first. The launch customer that we had is an extremely hoi polloi, posh, high-end dentist in Knightsbridge, and they look after Hollywood stars and VIPs and people with amazingly good teeth like Jurgen Klopp. And they've got, you can imagine that kind of dentistry has funds, and their customers have expectations. And during the coronavirus pandemic, that was a big driver for them. It was also, in their case, driven a little bit by regulations, because being a dentist, when a person sat in a chair and left, they had to leave that surgery furlough for a period to allow coronavirus to fall and then be cleaned. And we were able to show that we could halve that furlough period and prove that it was safe. And so they invested and put some of our arrays into their dentistry. That was our launch customer. And then, beyond that, we're looking, there's a lot of people come to us and say, we're looking for a USP. So in the food and transport industry, Eurostar, how do we keep our drivers safe? So these are areas where, which have to be cleaned on a regular basis to keep their drivers safe. It's the same in aircraft cabins, which we're also doing. And there's a lot of electronics, and they don't want to use fluids, but they are incredibly dirty environments once you start to swab them. I mean, honestly, the joystick and the handle in an aircraft cabin are about as dirty as a toilet seat. It's shocking, especially for someone who used to fly a lot. So, and then there's also things like the food industry. We work with Kellogg's, and Kellogg's have a requirement for dry cleaning inside their factory. They can't use fluids because of the food, and so we're in there. And then sanitization generally. We work with Mighty, huge sanitization company, Churchill likewise through the train contract, and who else? Initial, who used to be called Rent-A-Kill. They haven't taken any of our products other than on test, but what they've said is there are things that we're doing, which is the stuff I can't talk about, which will give them a USP that the second we have it matured, they're buying the products. So those are sort of kind of the launch customers, is people looking for USPs, people with very specific cleaning requirements, or people who want to offer that extra level of sanitization in their facility that their clientele, customers and workforce demand. That's where we've pushed open an open door.
So, given you've obviously got some great momentum there with some sort of first movers, getting your crystal ball out and from the kind of what you're hearing, what's the market going to look like, and what's the next 2-3 years look like for overall market adoption? Is the word going to spread? Do you think you're going to overcome at scale perhaps some inertia and these other things we've talked about?
Yeah. So we've already seen that happen in the US. So the kind of things that we're into commercial and bidding discussions with now, Federal US jails, amazingly, they're installing this in jails before they install it in hospitals, which I find surprising, but it's a fact. We have a very large ambulance manufacturer that want to install inside the ambulance cabin, so that whoever they pick up by way of patient, the cabin operator, the paramedic, is protected. And that's quite an interesting conundrum to solve right there, because the lamp is so close to the paramedic when they're standing up. So we're going to have to put some AI into the lamp so that it will amend its own exposure levels for the proximity of that person. We're going into a pilot right now in a set of schools in the US. I won't say where, but if they're happy with it and we get through US electrical regulations, which should be no issues for us, then we go straight out into 278 schools. There's immediate scale up there. Not us, but there are tourist locations in the US, like Seattle Tower, that's already got it installed. So we've seen that in America. But over here in the UK, I've been talking to Atkins, for example, for the next Heathrow terminal, and having it installed there. And really, I suppose one of the reasons why I'm with RICS, Andrew, and one of the reasons why we come to you is it's what we don't know. We're an aerospace company. I'm an aviator by trade and by knowledge, I guess. And it seems to me that it's going to be new facilities, probably more than old legacy facilities, with all the issues that come. We have been installed in NHS hospitals, and the fear amongst facilities managers for unearthing asbestos, for example, when they try and do a legacy fit, is just immense. So I suspect that your new modern buildings are where this kind of technology will first appear. And then it will catch on from there. Obviously, you'll have much lower installation costs in that instance, at the very least.
No, I suppose, thinking that the next sort of 2, 3, 5, 10 years, I guess, as you're aware, there's, as well as this whole well-being agenda for buildings in terms of making sure that these are safe places for people to occupy for whatever reason, with also the current focus on energy and sustainability, there is an increased activity in the retrofit market, because people are having to look at assets, particularly where there's a lease break or an opportunity to take an asset apart to some degree, to actually refit them for a number of purposes. And I guess, would you hope that this would be part of that refit agenda, as well as looking at energy performance and other issues and reformatting office floor plates for different kind of styles of working? Would you hope that this becomes part of the almost the retrofit checklist, if I can use that phrase, to say, okay, well, we're looking at this building, we have an opportunity now, it's empty, we're going to take it to bits to some degree anyway to do these other pieces of work. Would you hope that this becomes part of the almost dare I say, a hygiene point of, well, how are we going to maximize the hygiene of this building?
Yeah, I would say that is the case. I mean, one of the things that we've started doing recently, having reached out and understood your industry a little bit better than ours, is that facilities management software appears to be changing. So we've talked to some of the more modern facilities management software providers, not Fujitsu, just in case they do it as well. And what we found was that there was a real interest in approaches to air sanitization and health in buildings with these new providers. It's not just about this light needs changing. When was the last time that piece of equipment was serviced? It's not just pure management process. It is about providing an environment which actually tells the user what the ozone level are, what the CO2 levels are, indicate health hazards that are associated with those sort of things, so that there is this desire to understand how safe is the air that we're breathing. There is also a desire to be environmentally sound, and there are things that we can do with our lamps with the AI inbuilt that we're working on right now. So I'll give you this example because it happened just the other day. We were sat in a conference room. The conference table would have taken 20 people, and there were 4 of us, and we're all sat around one end. In that instance, I would want our AI to recognize that and only turn on the far UV at that end of the conference table whilst we're in that block of air breathing it. And then when we leave, it would turn on the lamps at that end of the table to full power to clean the table surface, and all the other lamps into a safer, a lower level of power, just to clean the air block quickly, ready for the next user. So you can have AI responses that optimize your power output. And then the other thing that people were interested in was actually having a human interface and understanding all of this data, whether that's a simple traffic light system on the wall to say this room is safe, or something more complex is TBD. So facilities management shows us that everything's changing, but also we want to get to a price point which is massively competitive with a modern HVAC upgrade. with UVC embedded, which is a pretty big, as far as I understand it, a pretty big change to make to a building. Plenty of ducting, massive amounts of holes in walls and ceilings, and structural studies have to go with that, as opposed to just sticking a ceiling light in with power, which does the same. It sanitizes the air, but it also gives you sanitization of surfaces as well. So yeah, legacy is definitely on our roadmap. We just don't know yet whether or not we can get to the point that we are competitive with HVAC. I'm not saying that we're not right now. I just don't have the experience to say we are.
Indeed. Well, you know, in many respects, early days, but obviously a very exciting path you have here to work on the next few years. And for better or for worse, you know, post-COVID, I think there's clearly an awareness now that we have to pay much more attention to these kind of things in terms of making sure our buildings are safe and attractive places for people to occupy. But for today, Mike, it's been fascinating. I've certainly learned an awful lot today. So thanks for your input. It's been great to chat.
Angie, thank you very much. Great to chat. See you soon.